Oh, beautiful. So that we see how change of subject is going to be. Well, change of subject is a very big topic. Change of subject. It is a very big topic. Change of subject. Okay, it's a very big topic in the sense that in every sphere of life, when it comes to mathematics, physics, chemistry, economics, in everywhere you go, we need change of subject. So, change of subject, what is it? We've been doing change of subjects ever since we were born as little kids when we started learning mathematics. Why am I saying that? Now, if I give a child a box, like a box like that, and I say this is a box, then I say this is 6. Well, a child can look at this and say, well, it's box and one box, give me that. So the child will say, a child will say, okay, this is 3 and 3. Well, somebody also will say 2 plus 4. Okay. And somebody will say 5 plus 1. Give us 6. And etc. It's all, our answer we get for this is 6 in all. So, then it became very interesting. Are we going to do that for every box, every question that we've been given? If we have been given a box like this box plus box plus box plus box is equal to 28. Okay, so we know if we have 4 boxes equals to 28, then we can say that each box as it is can be 7, 7, 7, and 7. That will amount for it to be 28. So when we come to change of subject, you see, this approach, we will usually, mathematically, represent them with variables. So instead of this being 3 plus 3 over here, instead of this one being 3 plus 3, okay, 3 plus 3, like that, we will say let this one be x plus x, which equals to 6. And that will help us to be able to find the answer rather than to suggest and assume certain values that, in a nutshell, it will take us number of hours and period to be able to solve it. So likewise, in the same way, now we know that 7 plus 7 plus 7 plus 7, that will give us the 28. Well, so we say, instead of writing 7, we say x plus x plus x plus x is equal to 28. So meaning, now let's look at the first one. The first one here, A, and this one is B. All right. Okay, so if that is the case, let's look at them individually. So if we look at A, we realize that we have x plus x equals to 4. And B, we have x plus x plus x plus x equals to 28. So with these two solutions, okay, and knowledge to be able to find the values of x for both scenarios, scenario A and scenario B, the knowledge and the use of change of subject will be matter to us, because if I take A, I know I'm going to get x plus x, which is 2x, is equals to 4. Okay, then B, I'm going to add x plus s plus a plus x. So, for basic mathematics, for us to let a student have a grip in variables, the use of variables, we say 1x, 1s plus 1s plus 1x, so 4 1x. So that will give us 4x is equals to 28. Okay, so how do we find our values of x for both scenario? So let's look at scenario A. Scenario A. So scenario A. Scenario A, we have 2x is equals to 4. Okay, and we know that in such case, case A, it means that 2, the number 2 is multiplying a variable x. So you see, so number 2 is multiplying a variable x. So the interpretation of this very equation is the same as saying 2 multiplying x is equals to 4. Okay, so note that note for x, or for variable x, for variable x, for variable x to stand alone, is referred to as change of subject. Okay, so it's referred to as okay, change of subject, or it's referred to as change of subject. Okay, right, so it's referred to as change of subject. So you see that all those years we've been doing change of subject, but it wasn't named, or they didn't define to us as we are doing change of subject, because the change of subject as it is, yes, is nothing by making the certain variable to stand on its own, and it comes in different form. So as we can see, we realize that 2 is multiplying x, and the answer is equals to 4. So if we don't want to complicate ourselves, we know 2 is multiplying x, and for x to stand alone, you see, so for x, for variable x to stand on its own, okay, so for variable x to stand on its own, we have to do something, because 2 is multiplying x and is equals to 4. So we have to do the inverse. Okay, we have to do the inverse. Okay, so we have to do the inverse for multiplication. Okay, so we have to do the inverse of multiplication. Okay, and that is division. Okay, that is division. So since 2 is multiplying x, if we want x to stand alone, we have to do a division. But bear in mind that 2 multiplying x is equals to 4. This is the multiplication sign we have over here. So that to be able to get x to stand alone, we have to put our hand on 2. And when we do that, that will help us to be able to know that since there's a multiplication sign over here, we have to divide. Okay, but also bear in mind that since we are going to do a division, we have to do to both sides. Note, in every equation, in math, what we do to the left hand side, we do the same to the right hand side. You see, so this is very important to every equation and every change of subject we are going to do. So now, because of that, our equation or the scenario A, which we know it to be 2 multiplying x equals to 4. Meaning, since I'm going to divide, okay, and because of this multiplication, when I divide here by 2, I have to divide here by 2 as well. You see, so that what I've applied the simple mnemonics that we always should have it at the back of our mind. The left hand side must be equal to the right hand side. What we do to the left, we do to the right. So by so doing, we see that this will cancel this and we'll be left with 1 multiplying x. And we know 2 goes into 4 2 times. So therefore 1 times x is x. And the answer is equal to 2. So you see that we have made the x the subject. Okay. In the same way, when we take the scenario B, which we had 4x is equal to 28. We'll do the same thing. We're going to divide both sides by 4 so that x will stand with this. Means 4 multiplying x is equal to 28. So what I do to the left hand side, I do to the right. So if I divide the left hand side by 4, I got to do the same to my right hand side. So you see, this is the left hand side and this is the right hand side. So straight, we know this 4 will cancel this and will be 1 times x, which is x, and we get 28 over 4, which we know that answer is 7. So we see that we have made x the subject. So basically, change of subject is applied everywhere. So in doing change of subject, we will apply addition, simple subtraction, we will do multiplication, Okay, multiplication, division, square root, sine of angles, etc. But with all this, we got to remember what we have to know is we are going to apply what is simply called the simple mathematical adage to equations, that whatever you do to left hand side, you do to right hand side. Okay, so let's look at change of subject. For instance, if we haven't given, let's look at change of subject that is in the form of addition. Okay, so we have addition 1. Okay, so if I have x plus y is equals to 9, and the question says make y the subject of the equation. You see, so my question is this addition. It says x plus y is equals to 9. Where make y the subject of the equation. Okay, so what do we see? We know that x is adding to y, and they say the answer is equals to 9. Now I've been asked to make y the subject. Friends, what do? If we place our hand on the x, y is standing alone. But we know that y is standing there and being added by x. So we have x plus y is equal to 9. So there's addition over here. And we know that since there's addition over here, the inverse for addition will be subtraction. You see? So, you see, the inverse of addition is subtraction. Okay, look at it. So look at it. It's very interesting. So when I see things like that, I say, okay, now the question I've been given says x is adding to y, and the answer is equal to 9. And I've been made to understand that I have to let the y stand alone, because y is supposed to be the subject of the whole equation, so that I have to apply what I've been told right from the scratch. That what I do to left hand side, I do to right hand side. So x plus y is equal to 9. So what can I do? What can I do? Since x plus y is equal to 9, what can I do to make this x go away so that y will stand alone? Okay, this x is adding to y, and the answer is equal to 9. And I've been told that the inverse of addition is subtraction. Therefore, if I want y to stand alone, all what I have to do is to subtract x from each side of the equation. Because we've been told that what we do to the left hand side, we got to do the same on the right. Okay, so because of that, now I am going to subtract x from each side of the equation. So now, if this is the case, I will say minus x here and minus x here. Because I've been told that what I do to the left hand side, I got to do the same on the right. Okay, so this implies that x minus x will be 0 plus y is equal to 9 minus x. And I know 0 plus y here, when I add 0 to y, I'll get what? Y. So the n minus x, you see this. So this is the change of subject. I've made it such a way that I've been able to make the y the subject. So this, therefore, the y the subject. Okay, so it's not anything difficult. All what we have to do is to obey the principles, the rule that says what to do to left hand side, do the same to the right. So the x plus y was equal to 9 minus 9, and I subtracted x from each side for the y to be able to stand alone. So you see, in addition, we are able to do that. Let's look at one more example of the addition one. So I've been given another one. Okay, for instance, they say, make, the question will be, they say make A the subject, make A the subject of the equation, x plus xy is equals to a squared minus 1. S is equal to sy is equals to a squared minus 1. You see, this one, a squared minus 1. Okay, this is plus 1, a squared plus 1. Now let's look at this. We have been given such a question. Okay, yeah, such a question to solve. So they say make A the subject of the equation. So what do? If I look at the equation very well, so let's see the answer. For such equation, xy is equal to a squared plus 1. What are we seeing here? We see that x is multiplying y, but it's equals to a squared plus 1. It is still addition. Have you seen it? So what can I do? All what I have to do is to apply what I've been told, because I know this here is my left hand side and this is my right hand side. So what do? I got to apply what I've been told. So they say I should make A the subject. So what I have to do is to subtract 1 from each side, because 1 is adding to a squared. Okay, so if that is the case, knowing that xy is equals to a squared plus 1, what do? I have to subtract 1 from each side, because in the equation, what you do to the left hand side, you do the same to the right. So I'll subtract 1 from here, and I'll subtract 1 from here. Okay, so this will imply that xy minus 1 is equals to a squared. 1 minus 1 is 0. Okay, so this over here is a squared is equals to xy minus 1. Friends, you see that this, we can also write it like that, but it doesn't change anything, xy minus 1. But we have a problem. They say we should make A the subject. Therefore, well, maybe from here will be a little bit of advance to some people, but it's not going to change anything. If we have done something, a topic we call indices, that will help you a bit. So we want to make A the subject, but not a square. So remember again, they say what you do to left hand side, you do the same to the right hand side. So I'm going to take square root. Okay, so take square root to both sides of the equation. Have you seen it? We are still applying the simple adage that says what you do to the left hand side, you got to do the same to the right. So over here, our equation, that's where we are able to work up to. So we have a squared is equals to xy minus 1. So what are we going to do? We're taking the square root to both sides. So when I take square root to this and I take square root of that, I know square root of a squared is a. Why is it so? Why is it so? Now let's see. Okay, we have a squared, yeah, and this one is sy minus 1, which you cannot do anything about it. So, but this one, the square root sign over here means raised to the power half. Okay, this is also xy minus 1 raised to the power half. But that is not our interest. Because the square root of any number means that number raised to the power half. So over here, if you look at it, if you look at a squared multiplying this, means that when we take the bracket out over here, all right, we are going to have our half multiplying those two. It's equals to the right hand side. So now let's see. Let's go to the right hand side. Let's see. We know that this will be 2 times half base 2 over 1 multiplying by half. So this will be 2 over 2, which is equal to square root of xy minus 1. Okay, 2 over 2. Okay, if you have 2 divided by 2 means it's equal to 1. So therefore, a raised to the power 1, which is the same as a, is equals to xy minus 1. Hence, we have made the change of subject. So a is equals to that. You see, it was an addition that we saw over there, but we have also applied something we've learned over the years called the square root sign. Okay, so now that is where we are at the moment. Now let's look at one more example of the, because we said it's going to be involved with addition, subtraction. You see that so far we have seen addition, okay, we have seen a bit of subtraction, we have seen a bit of square roots, okay, we haven't seen multiplications, division, and the sign of angles. There's more. That's what we have to. That's why we say etc. Okay, so now let's see one more example where it involves multiplication. Okay, so now they say make t the subject of the equation below. So the equation below, say L plus QRT is equal to 7. L, so this is the question. L plus QRT is equal to 7. So make T the subject of the equation. T. So what do we do? Let's see, friends. This is easy as well if we are following the same rules. So our solution will be, we have been given that the L plus QRT is equal to 7. First and foremost, we must be able to interpret this equation, because we know to be able to interpret this equation, it means this L is adding to Q, and Q is multiplying R and multiplying T, and the answer is 7. Okay, so if that is the case, you see, QRT is composite. Okay, composite in the sense that they are multiplying each other, so they come in as one unit expression. But we see something. Let us apply what we have learned earlier. We learned that in equation, what we do to the left hand side, we do the same to the right. So being given L, being given L plus QRT is equal to 7, It means that for QRT to stand alone, I have to subtract, okay, L from each side of the equation. So I say subtract L. Okay, so you see we are applying the subtraction again. So subtract L from both sides. Both sides of the equation. Okay, subtract L from both sides of the equation. So what we're going to do is we subtract L. So let's say we subtract L from here and L from here. So L minus L, this will be 0 plus QRT, which is equal to 7 minus L. Bear in mind that QRT means they are multiplying. So over here, since they are multiplying, yeah? So let's make a note so that we don't forget. So note that QRT means Q is multiplying R and is multiplying T. Therefore, we have to apply the inverse of multiplication. So inverse of multiplication, which is division. Okay, so now we can see that our equation Q, instead of saying L blah 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 blah, now we know it's Q R T is equal to 7 minus L. So we have to divide, note, we have to divide both sides by QR. So divide both sides by QR, because QR is also multiplying. Okay, so when we say that, we divide both sides by QR, so our QRT, which is equal to 7 minus L, we are going to divide here by QR, here by QR, because we know that what we do to the left hand side, we are to do the same to the right hand side. So we are going to divide both sides by QR. So when I divide here by QR and here by QR, what do you see? We straight on, we know that QR will cancel QR. So therefore, our T is equal to 7 minus L divided by QR. See? So we have made the T the subject. Okay? Now, let's see one more example. Okay? So another example. If we have something like V is equal to U plus 80. Okay, V is equal to U plus 80. Let us write it well. V is equal to U plus 80. Now the Newton's first law of motion. Equation of motion. Okay, now that is not what we are interested. We've been asked to make A the subject. Okay, make. So that is one. Make A the subject. I. Make U the subject. Okay, triple I. Make T the subject. So look at this. One question. We've been asked to make A the subject, make U the subject, and make T the subject. So what do we see? We see that V is equals to U plus 80. So we can see that there's U adding to A and T, but we should know that anytime we see A and T is referred to as a composite variable. Okay, this is composite variable. Why do I say composite variables? Because there are two variables multiplying together, okay, and it becomes one expression. So therefore we say it's composite variable. Okay, so now to solve the first one, it says we should make A the subject. Okay, so this is the question. V is equals to U plus A T. Okay, then we learn that since this and this are together, they are multiplying to each other. Plus U, and this equals what? V. So what do I have to do? All what I've been asked to do is to make A stand alone. That is change of subject. So what can I do? What can I do? I should always remember that in every equation, what I do to the left, I do the same to the right hand side. So this one, I am going to subtract U from both sides. Okay, so subtract U because we, okay, want the AT to stand alone so that we can separate the A. So we say subtract subtract U from both sides. So subtract U from both sides of the equation. Okay, so what do I have? I have V equals to U plus AT. So what am I going to do? Subtract U from both sides. So I'm going to subtract that. So when I subtract U from here and subtract U from here, so this will be V minus U is equals to 0 plus AT. Okay, so this implies that V minus U is equals to AT now. You see, so we're gradually coming home, and we know that A is our interest. Okay, our interest is to make A the subject. That's the interest. Okay, so now since we know that V minus U is equals to A multiplying T, then to be able to stand alone means we got to do the inverse because of the multiplication over here. So the inverse of that will mean we have to divide both sides by T. Inverse of that means we have to divide both sides, of the equation by T, because we want A to stand alone. So see, by T. So what do we continue? So V minus U is equal to what? A multiplying T. So here I'm going to divide here by T. Remember what you do to the left hand side, you do the same to the right. So we divide here by T, here by T, and straight on. You know that T will cancel this T. So V minus U all over T is now equals to what? A. You see? So therefore, the change of subject is A equals to V minus U all over T. It's our answer. For the first one, that says make A the subject. The next one says make U the subject. That's C. Okay, so we're making you the subject of the same equation. If we are smart enough, you realize that we've done that alone, but let us do it together. This V is equals to U plus AT. So if I want to make U the subject, this U is my interest. Okay? The interest is to make U the subject. So the equation given is V equals to U plus AT. And as you make U the subject, you have to bear in mind that this AT, as we saw earlier, this AT is called what? Composite variable. So we treat it as if it's one variable. Okay, so because of that, okay, having our V is equal to U, okay, U plus AT, and I want to make U the subject, means since this is an addition, okay, to U over here, so the inverse of this addition will be subtraction. So I'm going to subtract, okay, subtract. So we subtract 80 from both sides. So we subtract 80 as a composite variable from both sides of the equation. So from both sides. So when we say that, if that is the situation, let us do it step by step. We have a V over here is equals to U plus 80. Okay, so V is equals to U plus 80. Now, let's see. Our V is equals to that. So what do? I'm going to subtract 80 from both sides. Let me symbolize the word so that I'll subtract minus 80 here, minus 80 here. And straight on, we know that minus 80, since they are composite variable, this 2 will give me 0, plus U is equals to V minus AT. And we know U plus 0 is U. So therefore, our U, which is the change of subject, is equals to V minus AT, which is simple. Okay, let's look at the last bit. The last bit is a make T the subject. Friends, let's look at it once again. So II says we should make T the subject. Okay, make T the subject. How do we make T the subject? From the same equation we have. We knew right from the scratch, the equation given is cos V plus 80. And our interest here, we have been told to make T the subject. Okay, we should make the T the subject. But we still have U here, which we cannot bypass to do our stuff. So before we take care of T, we have to take care of U. Friends, look at it very carefully. Before we take care of T, okay, we have to make sure that we do something so that we don't want to see the U on our right hand side. Because on our left hand side, we have only V. As you can see, our left hand side, we have only V. On our right hand side, we see we have U plus composite 80. Friends, what do? We know that U is there. And U, or what U is doing over there, is addition. So We know the inverse of addition is subtraction. So we're going to subtract u from both sides of the equation. Okay, so our equation given was v is equals to u plus 80. You see? So what do? We subtract u from both sides of the equation. So the 80 can stand alone, then we can deal with it. Okay, so now we subtract 80 here, and we subtract 80 here. So this two, 80 minus 80 is 0. Okay, and u is here. So u plus 0 is equals to v minus 80. Okay, so u plus 0, we know is u, which equals to v minus 80. So therefore, okay, we haven't finished. Okay, now friends, we got to watch it. You see, we are making t the subject. So what the interest is u, isn't it? We are not subtracting 80 rather. Okay, so let's look at it again. If you look at it very carefully, our interest was t. So since we have v is equals to u plus 80, we subtract u here and we subtract u here. Okay, so we have v minus u is equals to what? 80. And as we saw earlier, this 80 means they are composite. It means u, v minus u is equals to a multiplied by t. And our interest is to make t the subject. So what do? Since a is multiplying t, we divide both sides by a. Okay, so when I divide the left-hand side by a, and I divide the right-hand side by a, straight on, you will see that the a will cancel this, and we'll be left with t. So we have taken care of t. So t now is equals to v minus u over a. Therefore, our change of subject t is equals to that. Friends, it's beautiful. So all this issue of change of subject is not anything complicated that we're supposed to be scared of. You've seen that so far, all what we have applied is we have applied addition, subtraction, and division. Okay, now let's look at this question. Okay, the question says, look at the question. The question says, if v squared is equals to u squared plus 2ax, make a the subject of the equation. You see, this is the question. It says v squared is equals to u squared plus 2ax. Make a the subject of the equation. Friends, how do we go about this? We know for sure that on the left-hand side, we have a v squared. Okay, it says make a the subject, so that is I. And it says make u the subject of the equation. And after that, it says we should make x the subject of the equation. Friends, well, it may look like it's difficult, but it's not. When we look at the equation, you see that on the left-hand side, all what we have is v squared. On the right-hand side, we have u squared plus 2ax. Now let's see solution. Let's try and solve the first one. So our equation given by the examiner says v squared is equals to u squared plus 2ax. and we should make A the subject. So if you look at it very carefully, you will see that our equation here is the left-hand side, and this is right-hand side. So what do we do? Let's try and solve the equation. Beautiful. So now, our interest is to make this A, the small A over here, the subject. So, you know that before we can do that, we shouldn't see U squared. Here, this U squared over here, we shouldn't see it at all. You see this U squared? We shouldn't see it. We should get rid of it. How do we get rid of that? We have to subtract U from both sides of the equation, as we'll learn. So if this V squared, yeah, if this V squared is equals to U squared plus 2AX, then we have to subtract U squared from both sides of the equation. If we do that, okay, so let's use another color so that we'll be able to understand it properly. So we subtract U squared here, and we subtract U squared here. You see, so this U squared, we take off this, and that will be 0. So we have V squared minus U squared is equals to what? 2AX plus 0. We know that means 2x adding to 0 means 2AX. So what do we do? Our interest is to make A the subject. So A got to stand alone. It's A. So what do we do? V squared minus U squared is equals to 2S. We have seen something we met earlier. There's a composite variable. Why? Because they are multiplying. The meaning is 2 is multiplying A and is multiplying X. Okay? So we're not scared. Since we want this A alone to stand, then we have to divide both sides by 2x. Okay, so we know that what to do to the left hand side, we got to do the same to the right hand side. So, meaning V squared minus U squared is equals to 2AX. We are going to divide here by 2x. So the left hand side by 2x, the right hand side by 2x. So when we divide here by 2x and here by 2x, straight on, we know when we look at the right hand side, this 2 will cancel this and the x will cancel this, and we'll be left with A. So therefore, we said our A is equals to V squared minus U squared all over 2x. So this is the change of subject for A. Our other question says make U the subject. You see over here, we should make U the subject. So I make U the subject, okay, of the same equation we saw earlier. So V squared is equals to U squared plus 2AX. Then we should make U the subject. Friends, what do? We got to do something, all right, so that we don't see this 2AX again. If we get rid of this, which is adding to this, means my inverse will be subtraction. So I got to take all this composite these ones together, because they are multiplying together. So there's nothing, if they are multiplying, don't touch them. If we are subtracting, you see, so like this, to get this one rid of this. Since it's adding, I have to subtract 2ax from here and do the same on the left. So that the equation, in effect, yeah, it will be v squared is equals to u squared plus 2ax. So what am I going to do? I'm subtracting 2ax from each side of the equation. So I take 2ax from here. I take 2ax from here. Okay, we know that 2ax minus 2ax will be 0 plus u squared. So the right hand side alone, so it says this is u squared is equals to v squared minus 2ax. So therefore, our u squared is equals to v squared minus 2ax. We haven't finished. The question asks us specifically to make u the subject, but not the u squared. Okay, remember when we have u squared like that, as we saw the other day, if we want the u to stand alone, since u is carrying a square, we have to halve it. That means we got to take square root to both sides of the equation. So we say take square root to both sides. Okay, so take square root to both sides, okay, of the equation. So we see this, we have our u squared is equals to v squared minus 2ax. So we take the square root of that. Okay, so the square root of that will be square root of this and the square root of that. So what we do to the left side, we do to the same to the right hand side. And we know the square root of u squared is u. So therefore, our u is equal to the square root of v squared minus 2ax. Okay, so we have been able to make the subject of u. Alright, let's go and look at the last part. The last part says, make x the subject of the equation. So let's see. So I make x the subject of the equation. Make x the subject. So our equation, once again, is given as v squared u squared plus 2ax. You see right now, we got to make ax the subject. X the subject from 2a. So you see this? You can see straight on that our a, the x that we're interested in is here. And the meaning of this is 2 is multiplying a and is multiplying x. So we know that this is what? A composite variable. Okay, so we treat it as one variable. So now that we have that at the back of our mind, we know v squared is equals to u squared plus 2ax. And now to be able to let 2ax to stand alone, I have to subtract u squared from here and subtract u squared from here. So that I'll get v squared minus u squared is equal to 2ax. Okay? Now, this is multiplication. Okay? The composites, these ones are multiplying. Okay, multiplying. So therefore, The inverse of multiplication is division. So what do we do? So v squared minus u squared is equal to 2ax. We are going to divide both sides by 2a. Good. If we block this one, if we block this, only this, we see only x. You see, when we block the 2a, we see the x is the only one left. So that means we have to divide by this 2a so the x can stand alone. Okay, so now we got to do that. So divide here by that. Okay, so we're going to divide here both sides by 2a. So this by 2a and this by 2a. Straight on, you will see that 2a will cancel 2a. So to be left with only x. So therefore, our x is given as v squared minus u squared all over 2a. We made a change of subject. Friends, I think this way we will bring our new topic, change of subject. This is the first one, so we call this one the volume 1a. Okay, so we'll continue with volume 2a when we meet again. But in the meantime, please subscribe, and also make sure that you don't leave the bell standing alone. You got to click it so that you'll be the first person to be prompted if we have something coming up. You have a lovely day till we meet again. Bye.